Alright, certainly don't try this at home. You can see this mountain biker's constructed a ramp on the left side of the train. You can't see the ramp, but to jump this freight train with his mountain bike. So let's do a problem. Assume that the takeoff ramp is 18.7 degrees above horizontal and that the landing ramp's the same on the other side. The rider hits the takeoff at 14.5 meters per second. How far can he travel in the air before landing the jump? So we're going to calculate range. Let me show you here a little bit what we're talking about. So the rider approaches here at roughly 14.5 meters per second at takeoff. He hits a ramp, carries him up and over the train where he lands and travels back into the woods here. If the ramp angle, let's say, is 18.7 degrees above horizontal, and his initial velocity is equal to 14.5 meters per second. What would his range be? And range is found by taking velocity squared, multiplying it by sine of 2 times the angle, theta, over gravity. We know that the force of gravity is going in this direction at 9.8 meters per second squared. Alright, first things first, don't try this at home. Usually a mountain bike gap jump doesn't have a CN railway train in the gap. But let's assume that this is a mountain bike problem that we can solve in two-dimension projectile motion problem. And what we've got going here is we've got a rider who's shooting down a trail through the woods here at roughly 14.5 meters per second. That's his takeoff velocity. He hits a jump or a ramp that he's constructed on the left side of the train. Can't see it there in the trees, but the land angle is 30 degrees, and the launch angle is 30 degrees, and let's assume the land angle is the same. What we'd like to know is what is his range, or how long is he going to be in the air here to clear this gap. So we're looking at something that looks like this. Let me draw it for you. Let me find the proper tools we're going to use. Alright. So we know he's traveling down the woods along a single track, and he hits a jump at an angle of roughly 30 degrees. We notice that's a projectile motion problem. We know that this has both a vertical and a horizontal component. So it's motion in two directions. We know that the force of gravity is playing in this direction. So that's a 9.8 meters per second squared. We know that his initial velocity as he came into his jump was 14.7 meters per second, and that the angle at which he launched was 30.0 degrees. And our question is, how much air time? Which is really a question of range. So let's look at the problem like so. Range is equal to velocity squared. Oops. Times sine 2 times theta over gravity. So we can find the range by substituting in 14.7 for the velocity. Our theta is 30 degrees. Force due to gravity is 9.8, excluding all those units there. The range will be measured in meters. All right, first things first, don't try this at home. This is a serious gap jump mountain bike problem. Most of the time there's not a CN freight train in the gap, but our problem is such, this mountain biker comes down the ridge on a single track, and he's constructed a ramp here. So let's say he's traveling through the woods like so. It's a ramp. Clears the train, heads back into the woods. We notice that this is a two-dimensional projectile motion problem. There is certainly motion in both the vertical and horizontal direction. We know that gravity is going to work on a rider in this direction, and that's 9.8 meters per second squared. Let's assume that the launch angle here is 30 degrees and that the landing angle is the same, and the initial velocity is 14.7 meters per second. Find out how big of a gap this mountain biker is clearing, which is really a range issue. So problem we're solving here is change tools. Is a range problem, so it looks like this. Range is calculated by taking the square of the velocity and multiplying it by sine of 2 theta over gravity. So if you would, find out how big this gap is that our mountain biker has to clear to get up and over this train.